Uh, Not yet. No. Refreshing.
It takes a little time. I think now, yeah, yeah, it is perfect now.
Yes, yes. Now it's
Yeah,
coming. So, sir, can we start?
Yeah, now you can. It's going to be 10:04, now 5, so another 1 minute you can start.
Good morning to all. Today, uh, this is the 21st lecture series on radar meteorology, jointly organized by South Asian Meteorological Association and Advanced Center for Atmospheric Radar Research, Cochin University of Science and Technology. Being the 21st lecture in this series, all academic lectures have been over by last week. Today, this is a very important technical session from the industry and operational platform, because whatever we have learned over the last 20 lectures. So this technical session is very much important in this regard. What are the modern advancements happening in the field of microwave radar technology, and also regarding the application products, like the utilization of the IMD Doppler weather radar data to its maximum potential. I would say that being the very good capability of exploring many type of weather systems, DWR data in India is less utilized, and the potential is yet to realize. So that is why we have two eminent personalities for today's presentation. From the industrial side, Astra Microwave Products Limited is pioneering in indigenous development of microwave technology across various applications, from ranging from defense, space, all the way to meteorology and even other applications. So, and another talk from the none other than our Gajendra Kumar sir from IMD. He doesn't require any introduction, because Saravana Kumar sir is delivering for the first time. Now, I request Professor Somesh sir to propose the formal welcome address.
Thank you very much, Dr. Avilas. I hope I'm audible clearly.
Yes, sir. Yes.
Thank you. Yeah, good morning, ABM Professor Ajit Tyagi Saab, the President of SAMA. Today's distinguished speaker, Mr. B. Saravana Kumar, the General Manager of Astra Microwave Limited. Our second distinguished speaker, Dr. Gajendra Kumar, he is also a member of our advisory panel of this lecture series. Our members of the other members of the organizing committee, Dr. Avilas, Dr. Mohan Kumar, Dr. Rohini, and many others whom I'm not able to see on my screen because I'm using it, my mobile phone to join this webinar. So we all welcome you on behalf of South Asian Meteorological Association and ACARR, the Advanced Center for Atmospheric Radar Research at Cochin University of Science and Technology. As Dr. Avilas has already announced that we have completed 20 academic lectures, and this is the 21st lecture. We had scheduled for the industrial presentation, as well as the operational user agency, the India Meteorological Department. just for this information of Mr. Saravana Kumar, our distinguished speaker of the industry on behalf of the industry. In this lecture series on radar meteorology, we had registrations from about 48 countries and more than 1,200 people registered for this course from all those countries. This course was designed for the capacity building of the people of South Asia as well as the member countries of the non-aligned movement. We had eminent speakers, researchers, the scientists, the academicians as resource persons for this lecture series. The participants have various backgrounds. Some of them are researchers, some of them are professionals working on the meteorological surveys. Many of them are students, and some of them are also novice. All the lectures, the previous lectures, we have archived already on the YouTube, as already mentioned by Dr. Tyagi Sahab, and it's open to everybody for viewing. We have got good hits of all the past lectures that we have recorded, and I'm sure the participant will be also very much excited to hear from the industry representation. As usual, all the participants are requested to write their questions, if any, in the question and answer box, and that will be answered by the speaker at the end of his talk. So enjoy the lecture and have a good time. Over to you, Dr. Avilas.
Thank you, sir. Now I request ABM Professor Ajit Tyagi sir to propose the presidential address.
Thank you, Abhilash, and I'm very happy that we are able to organize this industrial lecture today, though there is a change of time, but because of the busy schedule of our colleagues from industry and IMD, but thanks to them for having agreed to deliver. As brought out, you see, the development in radar technology is very, very important, and it has been taking in a very fast pace. And it is better to know from the industry that what all are their developments taking place. First-hand knowledge from there is going to be very, very useful to all of us. And more so, we are happy that indigenous technology in the South Asia is being developed by Astra Microwave in the field of meteorology and especially radars. So this is a big, big achievement. And similarly, the use of these data, operational use and also for research, which is being enabled by the India Met Department by due archival. And we are thankful to Dr. Gajendra Kumar to have agreed to deliver another lecture on this important aspect, because most of the researchers complain about the data is not available and all that, which is true to some extent. But now there is an enabling mechanism by India Met Department. They are open to provide data to the research community. So that's a great thing. So let's make full use of today's two presentations. And as we are expecting that these will be available on YouTube, so the people who could not attend today will benefit from these lectures. So I'm thankful to Abhilash, entire organizing team, Shrikala, Rakesh, and of course our key members, Mohan, Rohini, and other colleagues. So thank you so much. It's excellent teamwork. I'm really very happy and proud of all of you to have gone through this long series of 21 lectures. Another 2 are left, one for exam and another the validity function on 23rd of November. So make it convenient to attend, because there's going to be a very eminent speaker, Dr. Vivekanandan from UCARR and CARR. So make full use of these lectures, and also continue to make use of the YouTube lectures wherever you have want to learn more. And also we will share the email IDs of all our resource persons with the topic, so that you can also try to get in touch with them. Thank you. and make full use of today's lecture and follow it up. All the best.
Thank you, sir. Now I request Dr. Rohini to introduce today's speaker from the industrial partner, Astra.
Thank you, Dr. Abhilash. So it's a great pleasure to introduce our industrial partner, Astra Microwave Products Limited. Astra Microwave Products Limited are incorporated in the year 1991 by a team of distinguished scientists with extensive experience in RF, microwave, digital, electronics, and management of high technology content projects. The company was formed sensing the need for a technically sound and powerful company that had the capability to indigenously design, develop, and produce critical RF and microwave subsystems and systems for both strategic and civilian applications. In its 33 plus years of existence, Astra has moved up the value chain and established itself as a leader in the design, development, manufacturing, integration, testing, and supply of systems and subsystems for radar, EW, missile electronics, satellite payloads, MMICs, and hydrometeorology products. Astra Microwave Products Limited infrastructure includes 3 production units and 2 R&D units that also include an exclusive space qualified facility. Astra today has an array of assembly and test facilities that include 3 automatic assembly lines for PCBA assembly, 5 class 10K clean rooms, functional test infrastructure that extends from 30 megahertz to up to 40 gigahertz, in-house environment testing facility, including EMI EMC facility, and a first for any Indian private industry near field antenna test and measurement range. AMPL is an A9100 reverse D and BS-EN ISO certified company. In the field of metrology, Astra has established itself as an indigenous manufacturer and supplier meteorological systems like SSPA-based Doppler weather radars in X and C bands, wind profiler radars, automatic weather stations for various users such as the India Meteorological Department, Indian Space Research Organization, Central Water Commission, and various state water resources departments for their weather and flood prediction and data dissemination purposes. AMPL has also established an extensive AWS and agro-AWS network across the country, having an installation base of over 2,000 stations. All these networks have a subset of sensors like wind, RH, AT sensors, pressure sensors, rainfall sensors, soil sensors, and the transmission equipment as well as peripheral required for an automatic weather station. Recently, as part of the augmentation of IMD surface observation network, AMPL has installed 200 number of GPRS-based agro-AWS for various Krishi Vigyan Kendras spread across the country. With these achievements under its belt, AMPL is targeting to move up the value chain using partnerships and help by the Make in India policy of the Government of India. Formulating appropriate policies, AMPL has started accumulating the resources required for this important task, including manpower, IP, and infrastructure. We welcome AMPL, and over to you, Dr. Abhilash.
Thank you, Dr. Rohini, for introducing the speakers. Today we have eminent speakers from AMPL. So I request Saravana Kumar sir. So now the floor is yours, sir. Please. Sir, your sound is not proper. You are not muted, but sound.
Am I audible now, sir?
Yeah, now it is. Okay.
Yeah, okay. So good morning, Abhilash sir, and good morning to Professor Someshwar sir and Ajit Yogi and Dr. Rogni madam for giving an opportunities for industry to participate in such a lecture series and give a perspective on how the product development has been happening in Indian industries, particularly addressing to the Indian requirements, and in the future we are also working towards the global requirements. So I am Saravana Kumar. I have around 25 years of experience in the field of microwave and RF hardware development for the radar application. Predominantly, I worked in the defense sector previously, and I've been very thankful for Astra Microwave to provide an opportunity to work on some of the meteorological radar. And I'm very thankful to my seniors who are eminent in this professional and who has made the roadmap for Astra's product in the meteorological department. And we have rolled out various products for the Indian industries. With that, I will go to my presentation, sir. Can I have my slides?
We need to share that.
I will share it, sir. 1 minute, just in case. Sir, are you able to see my slide?
Yes, perfect.
Yes, sir.
Yeah, thank you, sir. Today, my presentation is going to be on about Astra Microwave's products for the Indian Meteorological Department.
Sir, there
Yes,
is a
sir.
black screen coming inside of that. Is there any problem with that?
Is it okay now?
Some on top now. It's okay, sir. It's okay.
Oh, okay. So sorry for that. I've shared my full presentation, so I think the meeting screens are also coming, appearing on it.
Okay.
So before going into the our products, I've just given a brief introduction to Astra Microwave. Is a company which has been in existence more than 33 years in Indian industries. It has been started by 3 eminent scientists from DRDO. And it is became a public limited in 1994. And we predominantly work on the radar and EW systems and also for the space applications. We started the Astra Microwave started the RF activities in the telecom radar in 1991, and then for the subsystems, RF subsystems and modules, and moved up. And then when the next stage around 2000s, we started concentrating on the MMIC devices because some of the restrictions of importing the devices was there in the was implemented on India. So Astra stepped in and then started developing their own devices, microwave devices, and that has actually put on the Indian industry map advantage of making our own devices, and then relieved us from the Western countries, relying on the Western countries for major solution. And with our own devices, we started working on some of the state-of-art technologies. Moved up from the devices, we started for the major radar hardware like a TR module for active phased array radars, and started working on then for then airborne radars. And now we have our own radar systems being rolled out for instrumentation. And apart from the radars, which are all we have delivered for the meteorological department. This how we have been progressing over last 33 years. Not only on the radar domain, EW systems, we have complete spectrum of the product for the missile electronics and also for the satellite payloads. To achieve all these state-of-art products, we Astra have an infrastructure inbuilt into its verticals of various requirement to meet the to make the products viable. We have in-house multi-layer antenna facilities where we can able to whatever all the designs what we are doing it on the antenna side and the microstrip, we will be able to do a fabrication and we will test it in our facilities. We have the clean room for all our MMICs assembly and testings. We have an SMT lines for all our PCBs for an assembly and laser welding machines and die bonding and wire bonding facilities within house. So we not rely on any of the foreign vendors for packaging our own dies. We also have thermovac facilities for the bonding, for the autoclave, for some of the microwave PCBs to be bonded with our mechanical housing, and also we have packaging facilities with pressurized seal leak test. Also, we are having it. To evaluate some of our products, we have in-house all the facilities from the bench test of the individual modules and an ATE for automated test for the serial production to environmental test facilities to qualify our product to meet the environmental standards of our product needs. AMMC facilities, we have the antenna range facilities for the evaluating the antennas. And one unique facilities, NFTR facilities, a near field test range facilities, which have a chamber size of 17 meter and 15 meter by 11 meters, where our Tetra vehicle along with the radar installed onto the vehicle can be moved inside the chamber and can be calibrated for the active phased array systems. And the antennas will be all the error data of calibrating the individual TR module will be captured and the radiation pattern is being implemented. We have wide variety of all this individual test bench equipments. We can say that we are the one of the industries where we have more than 100 signal generators, spectrum analyzer and vector network analyzer, which are all the infrastructure which is all required for to meet the to produce the systems of the volume what we are signing up from the Indian requirements. These are the various product range. Predominantly, Astra microwaves have been working defense, space, and hydrometeorology and other product services. Apart from the product development, we are also offering the services of MMICs, contract manufacturing, AMMC, and PCB assembling facilities. To other our industrial partners and Indian industries, whoever the startups who are looking for such a facilities within India to bring up their products. To move on to meteorological radar, we have been for last almost more than a decade, we have been rolling out various meteorological radars products to our customers. X-band DWR radar, we have already been rolled out more than 12 numbers to IMD, and which has been installed and been operational at various locations. 10 radars are on the Himalayan range. And now we also delivered C-band Doppler weather radar, which is already one of the unit is been on the site. And remaining units are in the movement towards the site. So within another short span of time, we will be installing at the site and bring it operational. We have made one DWR on a mobile platform on a trailer mounted DWR system. And avalanche radar we have provided to one of our DRDO customers to the Himalayan range again. And we will go through individual subsystems and what are the technologies involved in building each of these radar in the following slides. First, I will take the ST radar, which we have developed and delivered for one of the customer, university customer. Calcutta University. This operates at 53 megahertz with an active elements of 475 elements. This we have realized with the distributed amplifiers, which is the TR module. a housed TR module of 2 kilowatts is been dedicated for individual element, and this 475 elements are being configured with 25 subarrays, and each of the subarrays having 19 elements, radiating elements. The photographs will be visible. This site can be visible from the Google map. So it's a big site spread around 400 meters. Around 40 meters it is being spread around. And this radar, which has been commissioned and been operational for quite some time now, which has been used to study the atmospheric wind velocities for a height coverage of maximum of 20 kilometers with a resolution of up to from 50 meter at an altitude of 3 kilometers and 150 meter of resolution from 3 to 20 kilometers of altitude. We have the capacity of the measuring the wind velocity of up to 70 meters per second wind velocity with an accuracy of 0.1 to 30 meters per second. This planar antenna array, which is consisting of 470 elements, which has been realized with a 3-element Yogi antenna. And all the TR modules which is required for the individual subarrays of 19 elements, all the 19 elements are being grouped. And there is a central hut is been planned where this all the TR modules and the group controller and the temperature control units are being housed inside the hut. Because all these TR modules, which is generating around 2 kilowatts of power, have to be the thermal management have to be in place to ensure that the system is being reliable and being operational without having any issues. A lot of the efficiency of the individual TR module is around 30%. So a lot of heat is being generated at this TR module. So we have to have a thermal management requirement for to maintain this system. So there is central hut is being designed and installed at the middle of the subarray of 19 elements, and this has been monitored by our sensors, temperature sensors, and there are two controlling thermal management systems are being there. Air conditioning system is being there, which are constantly is being utilized, monitored the temperature in the hut and manage the thermal situation in the hut. And all the electronics, group level controller, the triggering and the clock distribution unit are being housed within this shelter, the central hut, and remaining all other processing unit like the master radar controller, the timing and the clock generation unit, and the exciter, radar exciter are all being housed, and the 18-channel digital receivers are all being housed inside a control instrumentation room. The interface between this control instrumentation room to the individual TR module and the group level controls are being achieved by the fiber optics. Considering the EMI issues, which a large amount of power is being radiated into the atmosphere, so we have gone with an optical interface from the individual hut, from the all the subarrays to the central instrumentation room. And our own software data processing unit and the calibration unit is being also housed, and constantly it monitors individual TR module power output and the health of the all the TR module online. It can be monitored, and it will we will be able to process, and the data is available over the remote location, which has been shared through the network. Moving on to we have also done one more wind profiler operating at L-band frequency, which is the semi-active phased array system, which is being installed for one of our customer IITM. This is have a peak power of 3 kilowatts, which and a maximum height of 12 kilometers depending on the various seasons and the attenuation in the atmosphere. It's also able to produce the various products required for the wind to measure the wind velocity. And this is also been successfully installed. This type of wind profiler, we have done it in the various other frequency band also. Currently also we are working on one more wind profiler systems at VHF frequency. This is another VHF frequency which is operating around 200 megahertz. It is a fully active phased array system. Similar to our ST radar, this is also having a 19 element hexagonal shaped subarray, and this subarray can be added. More subarrays can be added to have a required aperture product for the system. This subarray, which is totally radiating around 16 kilowatt. This we have developed, and we also have one unit for some of our R&D purpose within in-house in one of our unit. Coming to Doppler weather radar, we all know that the weather radar in existence for more than from the World War time. Once the radar is in operational, where the weather is been attenuating the radar signals and the existence came. Most of the weather radars today in operationals are mainly having a transmitter with klystron based transmitters with a very high peak power and with the challenging power supply requirement for those transmitters. When the requirement is being plotted for the Indian requirement in X band, we have delivered a solid state power amplifier based weather radar. The solid state power amplifiers have major advantage when it is compared to the klystron based transmitters, which can have a duty cycle of up to 10%, so the average power requirement can be met, and the peak power requirement is being brought down drastically, and this is more reliable because there are many devices are being used to build it, and then the thermal requirement and the space occupied for this SSPA based transmitters provide an advantage. We can move the transmitter up in the pedestal and close to the antenna to reduce the system loss factors, and which will bring the total loss factor in the system calculations for the same range requirement, and also to bring that will add the benefit of bringing down the total transmitted power required for generation for the range requirement. This we have built with the 400 watts SSPA, which is been adding up around 8 devices and to generate the required power output. This SSPA is requiring around 0 dBm of power input. It is the 400 watts is being generated in a stage wise. Pre-driver amplifier is solid state amplifier is being there to generate the driver amplifier, and this driver amplifier is generating the power to feed the front end power amplifier, the high power amplifiers, which will be combined again through the power combiner to realize this 400 watts of output power. And the health of these SSPAs are being constantly monitored. The cold plate, the cooling requirement, everything is being housed inside the chassis in a 19-inch rack unit, which is been integrated with the thermal solution to the SSPA. The what you're seeing over here is our SSPA module, where you'll be seeing there is a boundary which has been marked over here. These are the various building blocks of this solid state power amplifier, where the driver stage, the final amplifier stage, and also the power supply for the pulsing requirement for this power amplifiers, energizing and the storage capacitor, and there is a digital control unit is being housed along with the power amplifier, which will be constantly monitoring the power output level and the temperature to maintain the health of the systems. So there is an triggering mechanisms when there is a reflection in the output port is being monitored. It is being sensed to protect the devices. The power supply will be cut off, and also if there is a rise in the temperature, and if it is meeting the threshold level, if the temperature rise, if there is any issue with the thermal management system, and that is also been constantly monitored 24/7, and that has been reporting, and the radar operator also will be having this health information of the individual SSP online, and it will kick in whenever the threshold is being met, and the cutoff will be implemented by controlling our power supply. For this X-band DWR radar, what we have delivered to IMD is of 12 numbers. All the electronics what is being required for to generate the generating the signal and amplifying it, and the transmitter and the analog receiver, all the power supply unit along with the digital control unit, everything is being housed over the pedestal inside the dome. And the analog receiver portion is being digitized, and the IQ data is being streamed over the fiber to the central operator room, where all the processor, the servo control system, the radar control unit, display unit, and the UPS for the entire systems are being housed, which is being housed in a separate instrumentation shelter on the down of the tower. Along with this instrumentation shelter, the generator also has been supported, and along with the UPS to provide the to ensure that it is operated 24/7 without having any power interruption. This is the technical specification of our radar, which has been operating. It is operated at 9.3 to 9.4 gigahertz of band, which have an 1 degree of beam width. The antenna, whatever it is been installed into the system, is a reflector-based antenna. It's a dual polarized antenna with 1 degree of beam width, which is indigenously developed within the country. And the system is being configured to have a sensitivity of 13 dBz at a range of 100 kilometers, and a maximum velocity of 45 meters per second. This range resolution of 75 meter, we have for achieving this target parameters, we have optimized our transmitted power requirement to 400 watts. Even though the SSP has been designed to have a little more power than what is the minimum power requirement, keeping in mind the gradual degradation over the time. So for minimum of 400 watts of power at the individual channels have been ensured. So the various products of the radar, which has been displayed over here, which is we have been partnered with someone of the OEM for producing these products. This is the C-band Doppler weather radar, which we have currently made 4 systems, and one of the system is being commissioned in one of the IMD site, and very soon it will be integrated into the country's network. This is since it's a C-band system, and it is having a 4.2 meter for the same angular resolution. The systems required around 4.2 meter of antenna, which is also been similar to X-band DWR. The pedestal is being housed with all the electronics what is required for both transmitter and the receiver functionalities. The waveform card, the digital control unit, the power supply unit, and SSP, a solid state power amplifier unit. Everything is being housed inside the dome on the pedestal. This is a unique approach configuration what Astra has been proposed and achieved it by having the 2.5 kilowatt of SSPA onto the pedestal itself. It has reduced a lot of loss factor into the system. So by that, our total power requirement for the transmitter is brought down to a larger extent because of the reduction in the loss of waveguide plumbing what is required from the transmitter to the antenna. This antenna, reflector antenna, it is indigenously developed. At the feet of the antenna is been in-house. It is been designed and developed. We are equipped with various EM simulating software, CST Micro Studio, HFSS, and ADS and 2D. So we use this various software what has been in our disposal to make the designs what is required for the RF circuitries. PCB design, and also the antenna and various waveguide components. There is a directional coupler for the power monitoring, the forward power monitoring and the reverse power monitoring, to ensure that the operational and the health of the system is in the expected lines. This is the operating frequency of the systems, and as in the case of X-band, that 13 dB at 250 kilometer is the detection range capability of the system, the range resolution of 150 meter and above. The transmitter for to achieve this radar target parameters used is an SSPA to 2.5 kilowatts of power per channel. This is the various product what is being achieved in the systems. It will have a round trip, a second round trip cancellation as an additional features in the signal processing implemented into the software. Moving on to other meteorological systems, what we have supplied to our Indian customers, we have apart from the systems, sensor systems to monitor the weather data, for data integration and distribution and processing, and a central station, we have providing the satellite-based multi-mission meteorological data reception and processing units. We have installed at various locations for this requirement with various our partners. And these are the infrastructure what is being configured and delivered to our customers' requirement. All the processing units, storage units, and the network interface units, display, all are being configured to the industry requirement, and is all been installed, commissioned, and maintained by Astra Microwave. We have a separate team for managing all these requirements, 24/7 monitoring and operating to maintain the systems. In addition to that, we have more sensor integration systems for the weather stations, automatic weather stations. These are all been operated with solar cells and batteries, which are weatherproof systems, are installed at various other locations, which are all been networked, and there is a central station can monitor all the sensor data for the to get the various weather data what is being required, rainfall, RH, and humidity parameters. A lot of sensors are being integrated. These are the various building blocks of this automatic weather station systems, which Astra has been supplying. More than almost more than 1,000 systems are being supplied already, are installed in various locations. And the software, it's an in-house developed software for the integrating the sensors and data acquisition and processing the data, and also generating the human machine interface for operating this data and presenting this data. Moving on to, after meeting the current requirement, for the future requirement, Astra has been in the right place with the right technology. We have, since we have been having our own devices manufacturing facility, design and manufacturing facilities at various bands. Currently, what we are been deploying for the various requirements for the meteorology is particularly for the Doppler weather radars or passive radar technology. The world is moving towards the active radar phased array technologies, where the high power requirements are being brought down to very low power at the element level, and the power amplifier is being distributed over the aperture, which brings major advantage of improving the system reliability and have the beam agility, so that the volume scan and the importance where the target importance are being there, the beam dwell time towards the targets can be improved processing gain can be improved, and with the same amount of subsystem specifications, and we'll be able to achieve a better range performance, and also the resolution and the system reliability will be very much improved and to a larger extent. Currently, we have qualified one of our active array antenna unit for the LCA Mark 1 radar. It is an electronically scanning radar. The technology is completely indigenized. All the TR modules required for this unit and the antenna and exciter unit, everything is being done in-house. The same technology have a potential to migrate to weather radar applications, where it's only the difference requirement is it is a dual polarized. The weather radars require a dual polarized systems. So the migrations will take the stage by based by first introduced a semi-active phased array radar, where the electronic scanning capability in the elevation will be implemented and move towards the fully active arrays in the due course of time. Where the challenges of integrating a much more electronics than the defense requirement can be integrated into the system. Since already we have an airborne active phased array radar, this radar also can be converted into an airborne weather radar systems, which our team is been eagerly working now for some time for taking the building blocks of the defense radars and then building the airborne weather radar systems. Within a couple of years, we will be having our own product in the airborne weather radar systems also. This is our feature towards the radar for the meteorological department. And I hope that we will be catching up the Western world with modern technologies and our with in-house products and technologies, and we will be able to have a state-of-art technological product for all our users of application requirement. With that, I'll sum up my presentations, and thank you all for providing an opportunities to from the industrial side and to interact with the academics and our users in a single forum. It's a great honor for us, and thank you very much for the South Asian Meteorological Association providing such an opportunity. Thank you very much, sir.
Thank you, sir, for the wonderful presentation on the development, especially from the Indian side in the microwave applications, in the meteorological applications, and how the most modern Doppler radar means phased array capability to be built in DWR applications. And since Saravana Kumar sir has to leave early, so may I request all panelists to switch on their camera to have a photo session.
Yeah, others please. Rakesh ji please. Gajendra Kumar ji please.
Yeah. Yes. Ready? 3, 2, 1, go. Thank you. So
Thank you.
now it is time for Q&A session. There are few questions in the chat box as well as in the YouTube channel. So I request Dr. Mohan to handle the Q&A session.
Thank you, Dr. Village. And of course, a special thanks to our honorable research person. So I've seen many questions here. So in the screen, the first question is, how is 53 megahertz rainfall RF wave generated from CUSTR?
Sir, we majorly use PLL-based waveform card generation. So we have our waveform card generation with the PLL circuitry. So from the basic clock, we will generate it. We will use for various products based on the phase noise requirement. We use various oscillators to generate the required waveform. And then we will have a phased locked loop circuit to achieve to the required frequency.
Okay, many thanks. Next is from Sharad Krishna. Minimum detectable signal in mini wind profiler.
Right now, I don't have the exact value to the particular question, sir. I will ask the concerned team to get you the MDS value for the profiler system. We actually, all our receivers, MDS performance are very much comparable to any of the imported systems receivers. So we have been able to meet all our performance, radar range performance with our system. So I will get you the, please write it to us. Our team will want to go over the mails.
Okay, many thanks. And next is from on anonymous attendee. After SSPA in X-band, are you using any web guides?
Yes, sir. All our transmitter output, it is being used from the transmitter output to the antenna feed. The complete the transmission line is the waveguide. WR90 waveguides are being used. Both rigid waveguide and flexible waveguides are being used to contour it around the antenna to reach the antenna feed network. And we also have a waveguide based dual directional coupler on the path between the transmitter and the antenna feed to monitor the forward power and also the reverse power.
Can you elaborate more on 206 megahertz BASF wind profiler, please?
Sir, wind profiler, I will ask our respective team, to provide more details. Can write it to us. We will give the more detailed construction and what are the building blocks, what is been there. I've been more involved in the weather, Doppler weather radar, and we have a separate team to handle the wind profiler. So I will get the answers from the respective teams.
Okay, another one, just use two words, dual polarized radars, maybe he or
Sir,
she.
all our
Carl
IMD,
D. Wall.
yes,
Yeah.
sir, all our IMD radars are dual polarized radar. We have a dedicated transmitter for H and V polarization, and our antenna feeds are dual polarized feed. This will be one of the challenges when we move towards the future technology of active phased array radars, where all the radar transmitter and receiver electronics, distributed electronics are right behind the antenna element. For a dual polarized radar, there will be a into two factor with the available grid between the elements has to be packaged. That is one of the challenge. So mitigate this challenge, one way of looking as a semi-active phased array radar. That will be then our next venture, next technology. What we will be venturing towards the semi-phased array radar, where we will be utilizing the distributed transmitted power and able to achieve the electronic scanning in the elevation, and we will be able to achieve the dual polarization requirement also.
Excellent. So Astra Microwave Products Limited is just a very one of the, I think, largest radar industry in South Asia, I should say. So of course, I think from the attendees, many of them are researchers, early career. Maybe they have some thing in their mind that what would be the exact career or what kind of skill and knowledge is required to build a career in radar meteorology and technology development. Could you please give an essence on that?
Yes, sir. Like any other micro industries, the radar gives a lot more opportunities, job opportunities for various disciplines, which starts from basic electronics for the control electronics to antenna systems. All the disciplines are having various opportunities. There are many people who have a very good amount, a very good knowledge in the electromagnetic field are moving towards the antenna design. various antenna design challenges are being there when it has to be met when it comes to active phased array systems, where the wide beam and minimal mutual coupling have to be implemented. And now various substrates technologies are also coming in, like an electromagnetic band gap structures to reduce the surface wave propagation, to minimize the mutual coupling. And moving on to the transmitters, now all the transmitters are moved towards the GaN-based solution. Now we are all our SSPs are being built with gallium arsenide. The latest device technologies are being used, which will have a very good power with the available real estate. The power intensity is been very high for the GaN when compared to the gas technology. And more microelectronics engineers who are all graduating from the microelectronics will be very much required for this type of solid state devices, both in the microwave domain and also in the power supply domain. There is challenge in the power supply domain as in the microwave domain. The power supply requirements of whatever required for these devices to achieve the droop, the rise time and the fall time, and to meet the peak power requirements, the power supply requirements within the size. When you move towards the TR module for the active phased array radar, and the real estate what is available are very challenging. So the solutions what we are providing will be minimum component with the minimum real estate. So there are a lot more opportunities for this microelectronics domain. And digital, now digital beamforming is the state of art technology. Now people are moving towards the virtually forming the beam in the processing unit. So the digital electronics people have a much more scope than in the past. They are actually ruling enhancing the radar capabilities to the multiple fold, and signal processing and data processing application in this from the software side. The computer science people are making the man-machine interface and radar controller systems. So radar is a system which will provide an opportunities from all the discipline. In mechanical is one of the main system with all the types of sensors for the pointing accuracy of the installation place, and which has to be integrated with the map. So all the disciplines are having a lot of scopes in the radar domain. I'm happy that we are developing within our country. So all the engineers can look up for an opportunity in the core technologies where they are graduating.
Okay. Thank you so much. I think we are rightly discuss all the questions what are available. Just only yes, no question. Is the industry offer any internship activity or training for the professionals and researchers? Just yes or no?
Sir, I'll say yes and no, because being on the defense industry, it has certain restriction. But still, we will be able to expose some of. We are taking some MTechs. Yes.
Okay, fine. Thank you so much. Thank you.
Thank
I
you.
think the
Sir.
best
Thank you.
one program. Thank you.
Thank you. For
Over to you, Abhishek ji.
Yeah, thank you, Dr. Mohan, for nicely conducting the QA session. And hello, Tyagi sir, you want to add something? Hello. Okay, if Saravana sir, you will be staying or leaving now, or
Sir, I'm in the middle of one more appointment, so I have
okay.
to things.
Yeah,
With your
then
permission, I'll log out from the system if the session is been over.
yeah. Thank you, sir. The
Thank
formal
you.
thanks will be at the end of the talk, but for the time being, we all express our gratitude and thanks to you and Astra for accepting our invitation and delivering this nice lecture on the recent technological development in the micro area, especially for meteorological applications. Thank you very much, sir, for your wonderful session and nice interaction with the participants and the questions.
Thank you, sir. My colleague is there in the panel. Any questions and anything is been there, you can mail to us, and colleague will carry forward.
Okay. Thank you, sir.
Thank you.
Thank you. So we are towards the second lecture in this industrial presentation. So that is to be delivered by our Gajendra Kumar sir, scientist chef and head of Upper Division of India Meteorological Department, because he doesn't know any need any formal introduction, because he already handled sessions and he is part of our radar meteorology advisory committee of SAMA. So without much introduction, I invite Gajendra sir to make the presentation and interaction with the participants.
Yeah. Okay. Thank you, Dr. Abhilash. Can you see the slides?
Yes, sir, we can see.
Okay. Okay. So I'll tell you about the IMD radar network, our future plans and data archival. So right now we have a network of around 39 deployed radars, and in fact that includes radars of 22 S-band. Initially we used to have only S-band radars, then 2010 onwards we took to C-band radar, and recently in last some 4 or 5 years we installed around 11 X-band radar. So in the network, we have a 22 S-band, 5 C-band, and 12 X-band. And those are also involving many manufacturers, and majorly from Metastar, Astra, and Bell and Gammatronics. And some radars are provided by ISRO, and in fact, we are getting the data from ISRO. 5 radars belong to ISRO, and 2 Vesala and 1 Toshiba. So at present, this is the, you can see in the picture, there are many gaps and some areas which are not able to cover, and still that require a lot of apart from that, there are some shadow zones are also there. But in the recent year, or you can say last around 5 to 10 years, many radars have been included into the network. So if anybody is interested to know about the location, so this is just for the, already I told you around 22 S-band. So these are mainly at the that coastal belt and some areas on the mainland areas. So like Chennai, Kolkata, Machilipatnam, Visakhapatnam, and all the details are there on the slide. And C-band radar initially started at a time of Commonwealth Games, and that time it was installed at one is Delhi and another at Jaipur. And that was again initiative was Tyagi Saab's time. These installed Metastar radars and these Vesala radars all were installed. And now after that we have a radar from BSSC ISRO Trivandrum. And last 2 years back, one ISRO radar was installed at Mumbai, and we have a item installed at the Solapur radar. So that those are the C-band radar. Earlier, IMD was having only X-band radar at Srinagar, but recently in the last 10 years, and those 10 radars belongs to Astra, as earlier Dr. Saravana was explaining. So those radars are installed at Leh, Mukteshwar, Kufri, Jammu, Ayanagar, and Surkanda Devi, Banihal Top, Jodh, Murari Devi, and Lansdowne. And one radar was installed by ISRO at NIT Chennai. But in the last 2 years, I was there was a we wanted to upgrade the radar network, and we did the study like how many radars we require, and also we executed many projects in the last 2 years, and we were able to, or you can say, we were successful in issuing orders. So now we have issued the orders of around 32 radars. So, and now within 1 month or so, we will be issuing for 2 more. So 34 radars now will be inducted into the network. So if you see, the 39 is existing and another 34 are upcoming. So by the next year, this network will be of the 73 radar. So that the right side figure is the 73 radar network, and we are planning that that Raipur radar will be commissioned by the end of this month. And another these radars are upcoming at Raipur, Sambalpur, Bangalore, Guwahati, and 10 radars in northeast itself. And apart from that, Bhubaneswar, Kolkata, Varanasi, Pune, Lucknow, Jhansi. So many places now will be covering. So that will make, but still there will be some gaps that I'll discuss later. But now the coastal belt and some more areas will be well covered with this. I think, except some this Rajasthan area and some MP area and some gap areas. And those radars also now delivery has started of all those radars. And in fact, now 3-4 radars will be installed in the next 4 months. Or you can now every 2 months there will be one new radar will be inducted into the network. So next year that will be the many, I think 2025 itself, more than 20 radars are likely to be inducted into the network, because that manufacturing is almost over. Now that delivery of radars will start by mainly that start by January 2025. So the installation will also start by January. So January to December will be very good in terms of the radar into the IMD network. And but there are some, as I told you, if you see this picture, there are so many gaps. Still, when we issued these orders and we again conducted some beam blockage analysis, then we found out there are still some area which need to be covered. And in the meantime, Cabinet has approved a mission Mausam for the IMD. And under the mission Mausam also, we are coming up with many equipments. And with this, in this mission Mausam, we will be again going for another 53 radars. So that will be combining almost 25 X-band radar, 20 C-band radar, and 8 S-band radar. So with this 53 radars, each and every part of the country will be covered. And in fact, each area, this major mega city, we have planned, like 4 metro cities, we have planned that they should have, as in Delhi, that Delhi we have S-band, C-band, and X-band, all 3 kind of system. Similarly, we are planning for Mumbai, Kolkata, Chennai, and other metro network, so that because there are some cases when when there is a heavy rainfall, then the X-band radar is not that efficient, and S-band is more efficient. But when you have to see study the clouds, or you have to capture the light rain, then the X-band radar is much better. So ideally, all the cities, they should be equipped with a combination of X and S or X and C radar. So with that concept, we have now planned for another 53 radars. So then you can see this picture. This will be each and every part will be covered with the multiple radars. So I think that will be the one of the best thing going to happen in the IMD, or you can say for all any radar interest in the country. With this 53, we will be taking up the network to more than 125. So now we'll initiate the process for this. This will be up to initiate the process. So you can say these 53 radars we can expect by 2026, 26 and 27. 26 will be the some initial some few radars will come, but by 2027 I'm planning that to cover each entire country, and also apart from that we have planned for wind profilers. Already we are in a process of 9 wind profilers at the major airports or the which are the prone to the wind shear. And now under Mission Mausam also we are planning for another 10 wind profilers. So with this 10, this country will be equipped with the 19 wind profiler. So that will again because wind profiler is also a kind of radar itself, which is scanning vertically. So this will so the combination of the DWRs and the wind profilers will be the one of the very good thing for the forecast nowcasting, as well as the data assimilation for the other kind of forecasting also. And apart from that, we are also in the Mission Mausam, we are planning, we have planned for 25 microradiometer, because there are, from the aviation point of view, there are some areas we wanted to focus to have for more parameters. So this microradiometer also we have planned, and wind profiler. So that and some cities we have selected in such a way that the same city is equipped with the microradiometer as well as the wind profiler, so that can be a replacement to the radio sonde, or in fact we will be able to calibrate the this system with the help of radio sonde, and we can that will be the alternate data will be available at that station. And because another thing what we understood at the very with our brainstorming, that whatever is the ground data that is good for the ground truth, and but if we want to improve the forecasting level of the department, whatever is the forecasting capability, if we want to increase in that capability, then we need more vertical profile. So with this purpose, now we have planned for another 60 radio sonde stations. IMD already have a network of 56 radio sonde stations. Now we will be starting another 60. So that right now we have that network is around 200 kilometer, 250 kilometers. So now we'll bring it down with this another 60 radio sonde stations. So these are the, in the Mission Mausam, there are various components, but from IMD point of view, in the phase 1, 53 deploy the radars, 10 wind propellers, 25 microradiometers, and the 60 RSRW station. These are the major capital component or for the improvement in the this observation network of IMD. So apart from that, if we talk about the radar data center, basically IMD is having the radar data center at the IMD headquarters. And that we started when we started many requests. We started receiving 2010 onwards. We started receiving many requests for the data. So initially that data was available with the station only. So then in 2012, we started to archive all the past data. So from 2012 onwards, we are having the data of those stations. And that radar data is in the multiple formats, such as like net CDF. You can get the data in the net CDF, SD5. Now we are also starting in buffer format also. So that is available for the different user, whoever my tenure, when I have taken over, I have opened this radar data to all whoever is coming forward for the research and R&D purpose. I'm always allowing that request and made available. There may be a little bit delay, like suppose you get the data in 15 days or 1 month or something. That may be other thing, but you must have got the data. That's because none of the case has been rejected in the recent past, and everybody has been given the data. And IMD radar data is also utilized by the different app developers, and like Rain Alarm app and some other app developer app, and some website. They are also using IMD radar data to provide and also for their specific purpose. And with this data, there are centrally some products also generated in the radar data center that you can see. And so meteorological product, those generated generally, those are from this MaxZ, PPI short, PPI long, PPI V, then the precipitation accumulation, surface rainfall, then the volume velocity processing. So, and that network and all that already you have seen. So now for the radar data, infrastructure is having that high-end servers for processing. We have increase the capabilities of high-end servers, network switches. Now NAS storage is around more than 100 TB, and we have a workstation because we have been receiving many requests. So we have augmented our entire data center so that data can be made available and can be provided to everybody. Now, based on that, also we have a website where the different for our requirement we have made different mosaic, and those also we have provided, and also with the FTP server we are providing data to many organizations. So, like a major responsibility of the radar data center is the reception of raw data and images from all the radar stations, then archival of that data, then providing radar data to user groups, and we are also generating different products and daily monitoring of radar status. At present, we have a 39, and some of the dual pole radar, and some old radars are the single polarized. And so that archival of data is almost around 12 GB data every day we are getting, and that is getting in the net CDF and some IRIS format and GIF format. Also, image data we are getting in GIF format. So that's basically we are providing output in form of raw data, and that raw data is available in IRIS format as per the requirement, and then it is converted to the different format in the such as the net CDF and the SD5. So then data is shared in the real time with the different organization, and automated daily archival of data is also made at the headquarters. So like for our different, we share the data within department. We share the data with our modeling group, but our communication group for providing to other organizations, and satellite division, hydrology. And outside IMD, we are providing real-time data to this CMIWF, IITM, and also to Rain Alarm and the Windy website also we are providing. And also we are providing data to many students from many organizations and scientists and researchers. With the as per the with the MOU agreement, we are providing this radar real-time data to Google as well as to Rain Alarm map. But there are some limitation, like some data we have available in the image and raw data, but there are some stations which we do not have in the as raw data, which are available only in the image form, like this ISO radar, this Trivandrum, Sierkota, and of some of our IMD radar also, like Gopalpur, Kochi, Bell radar. These are actually not, due to some old format we are not able to convert. So these are available only in the form of image. But but mainly I think more than 30 radars are available in the form of image as well in the raw. And that's already we have discussed. And but there are some stations we are currently we are not able to provide, not data is not available, or radar is not operated at the Banihal, Solapur, Mumbai, Sierkota, Cherrapunji. So these stations right now data is not available. But apart from that, all other 33 station data is available. Now, still, I feel there is a scope of improvement, and now we have been developing a website for providing the radar data, so that you need not to write to me or to anybody for getting the data. We have developed a website, we have developed a system for the automatic data supply portal, as IMD, AWS data or any other data. For that also, IMD has started that climate and the data supply portal, and that's a Pune. Similarly, we have developed this radar, this data supply portal for the radar data, and that will also have the daily status report, and that we are planning, most probably, if all goes well, then we will launch in January 2025. We'll launch this portal. Then with this, this will be the facility to you, that you go to the website, you select the data, and if it is whatever way somebody has to, whether you have to pay or you have to get it free, whatever, you have to fill the details, and then your request will come to us, and we will make available the data. We will also make the timeline with that within 1 week or 2 weeks, whatever. But you need not to search or request anybody. Just you have to, all the data catalog will be available, that which data is available, that you will be able to see. Then you can select the data and you will get the data. And apart from that, we are also taken up because this much of means more than 100 radars are coming on the network. So now this overall managing the radar has become a very problematic. So for that, now we have planned for the radar data central server upgradation. That means we will be coming up with a kind of center that where this mosaic of all more than 100 radar on a single screen, and we are in talk with the industry, industry, not a radar industry, from the software industry, to process and available all the real-time data for the nowcasting, and for the, so that, but that's the time taking job. This will take some time, because that need to be developed. That's a very initial stage. That's in a very initial stage. We will come up with the expression of interest, then we will define the strategy. But that's what is my future plan for this, to manage the entire radar data. That's all. Thank you very much.
Thank you. Thank you very much, Gajendra sir, for nicely bringing out the future plan of IMD in expanding the radar network and making available all this data to the user community, including um, academics, research, and other operational agencies. So it is a very useful lecture, I would say. So I think our technical presentations ended up with a good note that we are pioneering in Doppler weather radar, and under the leadership of Gajendra Kumar sir I think this data, all this data will be made available to all researchers and academics, because after the IMD gridded data, there are a lot of, if we look at the citation of IMD gridded rainfall data, it is very huge, because that made available to the user community free of cost and anybody can download it. That way, if we can make the DWR data available in a standardized format, it would be more useful for the academics and other user agencies. I think I am sure that under your able leadership, you will be making available this data sets maybe by next year. We all are looking forward to that, and it was a very nice presentation and futuristic presentation, so that after the installation of 73 DWR covering the entire, I would say that none of our land will be covered with, all our land will be covered with, nobody will cry for radar further. So, so it is up to the users to effectively utilize this product. That is why we have to make this product in a very standardized, because since many type of radar is being used, the format, data structure and format is different. That is the main thing which is limiting the academicians to use these data sets. I hope that you will make this standardized, at least the read program for all the format. Format is another issue, because each radar is having different configuration. So each radar format is also very big thing. So I think you will take care of all these issues in future, and we all are here. We will work together to make this available to all user means agencies and user group and academicians and researchers. So it was a very wonderful and futuristic talk, sir. And with this, this is the end note that we are pioneering in DWR and radar meteorology. And this is end of this industrial presentation. I'm very thankful to you, sir, for making this presentation. And now I request Mohan, Dr. Mohan, to have the handle the QA session.
Okay, it's really nice. I think with these lectures, all the participants and community able to know that how radar cover is all over a very big country. So, and how it is helpful to the community, and also some pioneer initiative is taken to archive the data for the longer use and day-to-day use as well. So, one or two queries regarding the present art of the technique. Is there any artificial intelligence or machine learning will be used to improve radar data interpretation for nowcasting or flood forecasting? Is there any initiative, please?
Yes. With this, that's why I telling that this radar upgradation of that radar data center. That in that we are finding to one thing as mentioned by Dr. Abhilash. To like convert from all the radar data to one kind of data set and make available, and also make various products using AI and machine learning. That is also is a part of that project. So that with using to explore whatever the new kind of thing can be generated, new products can be generated using AI. That is also part of it.
Okay, fine. Thank you. So I have seen one important question in the chat box. How does the Indian Met Department support private industries like agricultural sectors or disaster management authorities in utilizing radar data for weather-dependent operations?
So, like IMD is issuing that agromet advisory. So those agromet advisory, they are misusing entire IMD data, radar data. Also, they are using that agromet and issuing the agromet advisories. They are using that data. And also this data is made available to in agro industry also, like Department of Agriculture is also taking some initiative. So it is also made available to them. So through them and through agro advisory, we are just providing help in radar data.
Okay. And also, but during any kinds of disaster, it is fully
Disaster, it
functional.
is always disaster for the
Yeah.
like any cyclone or anything. Suppose cyclone is happening or any big heavy rainfall event, those always can be detected using the radar. Means radar is the best tool
Right.
for detecting any cyclone or any extreme weather event. So that is why we have every day we have some request from disaster managers, and everybody wanted and was complaining that radar is not in my region. That is why we okay will fulfill demand of everybody. Let's everybody have the not to have any more complaint that if because even in this climate change time, earlier there was some region which used to have like extreme weather event, cyclone, but these days in last few years there are some many places which have experienced very extreme weather event. So radar is the best tool. Radar is the best tool for any such event.
Amazing. So, one important thing is that regarding the any kinds of weather related disasters, so there is actually no political boundary, especially weather never maintained. So, as India has a very large radar coverage. In addition, Nepal, there is also one. In Bangladesh, also there are a couple of radars. Even Myanmar, even some other countries. So, is there initiative will be in future? So, all radar coverage of the South Asian regions can make a very good radar hub. I think it would be a
Yeah, that can be that.
wondering in
Yeah.
please.
Yeah. Because right now, this like a cyclone and other weather doesn't extend political boundaries. So whenever there is a cyclone, using these radars, IMD is issuing the advisory and bulletins for entire this region. Not only for India, it is for the neighboring countries. For IMD is issuing the cyclones, and also like in the 5R region, aviation also significant whether using radar IMD is issuing. So that has no political boundary. Similarly, now with this, I think you have rightly pointed out that can be used as a hub for this, and some more research can be done, and some operation forecasting it is always used. So yeah, the only thing that there can be future that as surface observation, every country share with each other, and everybody is having the data of other countries. Similarly, there may be a time in future that everybody have a radar data of each other. So miss IMD radar data with the neighboring countries, and their radar data with the IMD, so that anybody can make use of that radar and in the operation forecasting.
Thank you. I think it is really needed. So I have seen almost, I think.
Yeah, Mohan, this is to be
Yes, sir.
a WMO initiative
Right,
to
sir.
come out with the format of the data to be exchanged, and what are going to be the, and some of the regional partnership also can be considered, but it's better to have a WMO like the satellite data which is being now shared, some of the satellite data by all the space agencies. So maybe that. So let's hope it's a need of the time, and I'm sure in the coming years it will be addressed. Thank you.
Thank you, sir. Thank you for your prudent comments. I think this is maybe the last question. Are there plans to improve access, such as creating a centralized, easily searchable database? I think you already mentioned in your lecture.
Yeah, already.
Maybe
That
you
will
you
be better.
wanted a bit more.
Just wait for 2 months. It will be centralized. Everything centralized. It will be available.
Okay. So it means within couple of, it means next year. Next year we will able to get the data for the research purpose,
We are
right?
planning because next January we have planned for IRAD. That's an Indian Meteorology conference. So my aim is to that inaugurate on that IRAD. If almost it is done, so I'm just planning to inaugurate that on IRAD.
Oh, similarly, complementary question: how to download and use double weather radar data available now? So I think same answer, right?
Yeah. No, yeah. So with that online, it will be available. Online through website, it will be available to you. You have to select the data, select the period, select the station, means there will be some fields, you select all that, give the request, then we will make available data to you with a defined timeline, and you can download the data.
Okay, fine. So is it available in Mosduck? Rizoy Rebello wanted to know.
Can you repeat?
Is it available in Mosduck? MOSDAC?
Yeah, it is available in Mosaic. It is available, but not in such a very good quality. That's why in that upgradation of radar data center, we are trying to bring the mosaic of all the radars, because right now it is available, but it is available for few radars, because those who have the common format and other radar which does not have a common format, that is not there. So that really that mosaic is our target.
No, I think he is asking the data available on ISRO MOSDEC site, raw data. That SEC has got a MOSDEC site where they provide satellite and other data. So is there radar data is available there, or the ISRO radars are available?
No. If that is he is asking, then it is no.
Okay, thank you.
Oh, okay. So it is the Meteorological and Oceanographic Satellite Data Archival Center, right? MOSDAC?
Yes, yes.
Yeah. Okay. So thank
That
you.
is
I think it is very
handled at SAC, Space Application Center. So
yeah. So I think it is very nice and very fruitful discussion, and it's covered almost all the aspect of the audience. Thank you so much, Gajendra Kumarji, and over to you, Abhirajji.
thank you very much, Dr. Mohan, for nicely conducting both the Q&A session with many questions from your side, which would be useful to other audience as well, and also nicely means all the deliberations from Gajendra Kumar sir also help the audience to gather more information. So I request Somesh sir to have few comments.
Okay, am I audible?
Yes, sir.
Yes, sir.
Oh, okay, great. Thank you very much. In fact, both the presentations made by the industrial representative, the general manager of Astra, Mr. Saravana Kumar, as well as the leading operational organization, IMD, presentation by Dr. Gajendra Kumar were really very interesting. In fact, it is like a befitting conclusion of the 20 lecture series on radar meteorology. This is the 21st lecture, of course. I'm sure the participants must have benefited a lot. I still see about 25 participants attending this session. So, and also the kind of questions which have generated during the two talks shows that the participants are really interested to learn and their curiosity. The first talk by Mr. Saravana Kumar gave an overall summary of the kind of different types of radar that is being manufactured by Astra, including the Doppler weather radars, the wind profilers, the phase data systems, and many more things. So that gives an exposure of the scope of the younger people who may be interested in more on the hardware side for the design of the radar, the antenna design, etc., which are very crucial for the Doppler weather radars or any kind of radars for that matter. So that was quite interesting. Also, the presentation by Dr. Gajendra Kumar was really very interesting, which gave a overall view of the current radar systems of the IMD as well as its future plans. I'm really very much delighted to know that IMD has now plans to have about 126 Doppler radars covering not only India, but also it will cover part of the many neighboring countries of South Asia. Already Bangladesh, I could see from those antenna coverage that the entire of the Bangladesh is being covered by the Indian radars. Similarly, most part of the Nepal, especially the southern part of Nepal. Also, the central part of Nepal will be covered by the Indian radars, except for those high mountain areas in northern side, which will be difficult to cover. But then most part of the Nepal will also be covered by the IMD radar network. Of course, Nepal has its own plans to have radars. Presently, I think 2 radars are there in Nepal. One of them is operational, other is just installed, and third is in the process of installation. So with that, Nepal, Bangladesh will be covered. I think part of the Myanmar also will be covered. So, eastern part of Pakistan will be covered. I think most part of Sri Lanka will be covered. So with this 126 Doppler radars, I think most part of the South Asia will be covered. So the most challenging part I see that will be to utilize these radar data in the NWP application, the numerical weather prediction, especially the data simulation. I know that presently many Doppler radars of India are being data from those DWRs are being assimilated in the model. But to assimilate all the upcoming radars in the future, and also all the radars data should be available on the real-time basis immediately. As you know, for the data assimilation on real-time basis, we need the data quickly on time. So that will be very, very challenging part. And also, I see that it will be kind of a boon to the NWP modelers as well as the researchers. Of course, one of the important application is for the severe weather detection by the Doppler weather radar, which is the best compared to any other kind of remote sensing platforms, whether satellite, as you know, it looks at the weather systems from a very far distance, but the radar looks at it from a very near distance. So all the closure intricacies of the weather systems can be seen by the different types of radars like X-band or C-band, and of course S-band is for the longer distance, especially for the cyclone detection, etc. But X-band and C-band are really kind of a good bonanza for the researchers and NWP modelers to look at. I can see that beside the data assimilation, the other important thing would be to also retrieve the cloud microphysical properties from these radars, which are very difficult to observe otherwise. Satellite does provide some information about the cloud microphysical parameters, the profiles, but then radar is the best thing to do that. And in my opinion, I see that there is a deficiency of research in that area to retrieve the cloud microphysical properties, especially the vertical profiles of the hydrometeors in cumulonimbus or in the severe storms in different parts of the country. So I hope that gradually, when the research community becomes more familiar or aware about the existence of such kind of instruments covering the entire India and parts of the South Asia, then they will be definitely interested in building up a climatology of the cloud microphysical parameters. For the reason, I know that some of the universities have written projects like Central University of Rajasthan. Presently, one project is going on, which is sanctioned by the Ministry of Earth Sciences, and the objective of that project is, of course, to study the cloud microphysical parameters retrieved from radars, and also the merging of the radar rainfall data with satellite and rain gauge. But then the merged data of rain gauge, satellite, and radar is already being produced by IMD and NCMRWF on real-time basis. But then definitely, it will be very, very interesting to study those things at a much higher resolution. Of course, radar is the one which can provide us the data at a very high resolution. So that way, still a lot of scope and challenges are there to investigate how good these data are at a high resolution, because as you know, rainfall has so much of variability both in time as well as in space, and particularly over the mountain region, it has got a lot of variability. So if we can generate the merged data of rainfall based upon radar, rain gauge, as well as satellites over the mountainous region, then it will be a very, very good database for evaluation of the model products, and also many kind of other climatological studies of the rainfall, etc. So a lot of the scopes are there, and I'm really delighted to hear both these presentations. I'd like to thanks once again Dr. Gajendra Kumar for elaborately presenting the IMD radar network, the data sharing policy. I believe, as he has already mentioned, for all the Indian communities, there is no issue, there is no problem, there will be no problem on getting the data. But for other countries, likely that they might have to develop some kind of a MOU or sign a MOU between IMD and those countries. So with that, they should also be able to get the data for their research. So thank you very much, Dr. Gajendra Kumar, and also once again, thank you to Mr. Saravana Kumar from Astra for very nice presentation. Thank you very much. Over to you, Dr. Avilas.
Thank you, sir. Thank you very much for elaborating on the challenges and the opportunities for utilizing the data and now I request AVM Professor Ajit Tyagi sir to have a few words.
Thank you, Abhilash. Well, apart from these two presentations, which were so insightful and very, very educative, comments by you and Somesh have done a great job in and I'm really happy and thankful to both the speakers who agreed to deliver these two important talks, a befitting finale to the 20 lecture series. And what I request Sama and the ACARR is that let's keep 6 monthly one lecture, at least 1 or 2 lectures from industry, and the update from the IMD's activities and other centers which are working the radar. Part of it, so that people are updated and we also know what is happening through the SAMA platform. So that would be good. So 6 monthly, 1 lecture series can be planned. Not series, say 1 or 2 lectures could be planned. Sky is the limit as far as the utilization of radar data is. Also equally important is capacity building. And I'm sure these academic institutions with this data available will set up some radar, I think, research activities dedicated. So that is going to give a real boost to the research come operational use of the radar data. So once again, thanks to both the speakers. From Astra, Vinod, I requested Vinod, who has deputed Shravan Kumar, and they had a busy schedule, so we had to shift the lecture in the forenoon. And thanks to Gajendra, who had been very, very supportive to our activities and agreed to deliver the second lecture, which is so useful to know the available resources and the future plans. So thank you, Gajendra, and I'm sure we'll continue to work with you, and the good work of IMD can be shared to the wider community. Thank you, and once again, ACARR led by Abhilash, Jai Ho. Thank you.
Thank you, sir.
Thank you, sir. Thanks. So we are towards the end of the session. So I request Dr. Srigola to propose the formal vote of thanks. You are muted, Srigola. Please unmute.
Okay. So this is visible.
Yes.
Good morning, everyone. I feel
put on the full screen mode. Maybe you can put on the full screen mode. Full view.
It's fine.
You can put your slide on the full
screen. Now fine.
Okay. So good morning, everyone. I feel honored and privileged to have the opportunity to propose the vote of thanks for the final lecture of the online course on radar meteorology, jointly organized by South Asian Meteorological Association and Advanced Center for Atmospheric Radar Research and Kochi University of Science and Technology on behalf of everyone present here. First and foremost, I would like to express my deepest gratitude to Professor Someshwar Das, Secretary Sama, for delivering the warm welcome address and setting the perfect tone for this event. A sincere thank you to AVM retired Professor Ajit Tyagi sir, President of SAMA, for his thoughtful address and highlighting the significance of our gathering and the ongoing initiatives of the organization. I would like to extend my heartfelt gratitude to Mr. V. Saravana Kumar. He's the General Manager, Radar Group, Astra Microwave Products Limited, for sharing his valuable insight on AMPL pioneering the future of Indian meteorology and technology. Your deep understanding of the industry and the way you explain the current trends, challenges, and the opportunities was not only informative but also thought-provoking. I also extend my heartfelt thanks to Dr. Gajendra Kumar, Scientist Staff and Head, Applied Division, IMD, for sharing your valuable insight on IMD radar networks, future plans, and data archival. Your knowledge has certainly broadened our understanding on the IMD radar network and the future plans of IMD to expand the radar network and data accessibility. I would like to express my sincere gratitude to Dr. Rohini Bawar for providing such a nice introduction to Astra Microwave Limited and Mr. Saravana Kumar. I also extend heartfelt thanks to Dr. Mohan Kumar Das for moderating both the Q&A section and for ensuring that the interactions were meaningful and engaging. Thank you to Dr. S. Abhilash for smoothly moderating the session and keeping the proceedings organized and on the track. Since this is the final lecture, a special thanks to the organization team from ACARR, Mr. Ragesh V, Mr. Rajay Rebello, Mr. Sharat Krishnan S, Mr. Abhiram Nirmal, Mr. Prabhadach Kurup, and Mr. Krishnamar E.K. for ensuring every lecture ran smoothly. Your dedication and teamwork are deeply appreciated. Finally, I would like to thank all of you, the organizers of the program, our esteemed audience, experts, and the participants for your valuable presence and insightful questions. Without your engagement, this session would not have been as enriching. Once again, a heartfelt thank you to everyone for contributing to the success of this program. We look forward to continued learning and collaboration in the future. Thank you.
Thank you. Thank you very much, Dr. Srigala. We also thank you for being being among the local organization team, and your efforts were also well appreciated. And also one more person from Astra is joined, Mr. Parizos, sir. Thank you, sir, for joining as a panelist for this session. And there are a couple of announcements. On 16th, next Saturday, we will be conducting the online exams, and that will be at the regular time, 3 p.m. And regarding the question papers and the examination schedule and other details, we will be sharing through emails. And see you then. And please, all those who want to appear for the exam, please join on 16th of November at 3 p.m. Thank you. Thank you very much. Good day. Is there any announcement?
Yeah, Abhilash, I'd like to thank the organizing team of ACARR. Thank you so much, each one of you. And I'll request each one of them that you are a great asset for SAMA. And if you have not become the member, life or the student member, please do join and contribute to the growth. Okay? So please do that. Thank you so much once again for your support and cooperation which you have done, conducted this series so well. Thank you.
Thank you, sir. Thank you. Thank you all. See you.
Thank you, everyone. Thank you.